Over the past few decades, the surface air temperature of the Arctic region has been warming at a rate twice as fast as the global average. Accelerated Arctic warming is in part due to melting Arctic sea ice and snow cover. The region has also seen greater trends and variability in the ecosystem than the rest of the Northern Hemisphere. This phenomenon is known as Arctic amplification, and it's strongest in autumn and winter. To explain how Arctic amplification affects the polar vortex, let's start by looking at the vortex in its stable or strong state. During the winter months, the polar vortex is a wide expanse of fast swirling cold air, flowing west to east in the stratosphere around an area of low pressure centered on the North Pole. Picture this area of low pressure as a bowl-shaped indentation of the stratosphere filled with cold air particles, shown here as blue dots. The heaviest and most dense of these cold air particles settle in the bottom of the bowl, weighing it down. When the vortex is strong, the cold air is confined inside the bowl, and the jet stream in the troposphere below it flows in a fairly regular path around the globe. Think of the jet stream as essentially dividing the cold air up north and the warm air down south. The large temperature difference keeps the jet stream on a straighter path, and weather patterns and storm tracks tend to be fairly normal and seasonable. During Arctic amplification, the increasingly warm air in the Arctic causes a kink in the jet stream over Eurasia. This sends warm air particles, shown here as red dots, into the bowl-shaped indentation from the sides, pushing towards its center and weakening the polar vortex. The hot air causes the pressure to rise over the North Pole, eventually inverting the shape of the bowl. During this redistribution of air masses, the cold air particles are displaced by the warmer air, rolling off and spilling away from the North Pole to the outer layers of the atmosphere in the mid-latitudes. In more extreme disruptions, the polar vortex splits into two daughter vortices. In this weakened state, air flows in a wavier fashion around the Arctic, meandering north and south, rather than flowing steadily west to east, and the redistribution of cold and warm air accelerates. The reduction in the temperature and pressure difference between the Arctic and the tropics robs the jet stream of some of its strength, causing it to meander, sometimes dramatically, to the north and south along its path. These large swings in the jet stream allow cold air to push further than usual into the southern portions of the hemisphere, creating weather events like Arctic air outbreaks and severe snowstorms, and warm air to penetrate deep into the Arctic, resulting in unusual Arctic heat waves. The profound changes to the Arctic system have coincided with a period of more frequent extreme weather events across the Northern Hemisphere's mid-latitudes. The potential link between Arctic amplification and changes in extreme weather is a critical one, as this phenomenon can be expected to continue over the coming decade.